Hey everybody, Dr. Gallegos here, and today we're going to take up our work where we left off the last time. If you remember the last time we talked about the vertex form of a quadratic function. Today we're going to look close at the standard form of a quadratic function, and we can look at it through this way. This is the standard form f of x equal ax squared plus bx plus c. Now, the values a, b, and C give us some really important information about a parabola that is the graph of this function. So the other thing that we just need to remember is that a is never equal to 0. We can never have a, which is that value right there, that coefficient in front of the x squared, is not going to be equal to 0. So if we look then at a quadratic function that is in the form f of x equal 2x squared plus 8x minus 2, we're going to look at certain values of this that are given to us from the a, b, and c values here. So here we know that the a value is 2, the b value is 8, and the c value is 2. So these values are going to give us some information about the range of this function. It's going to give us information about the vertex of this parabola once it's graphed. And it's going to give us information about the minimum value. And finally, it's going to give us information about the axis of symmetry. So we're going to be on the lookout for the range, the vertex, the minimum value, the maximum value, and the axis of symmetry to see where that is. So since we're over here in Desmos, let's go ahead and plug in our values and graph this and then sort of take it from there. So we've got y equal 2x squared plus 8x minus 2. All right, so I'm going to go ahead and hide my values here. I'm going to go ahead and give my steps here. I'm going to let it go by steps of 1. So get them in radians, and I've got that done. Okay, so we've got a parabola here, and we're going to look to see what our important values, if you will, are. All right, so if I go over here, we're the vertex and axis of symmetry and the maximum and minimum values. So over here we have a vertex that is sitting at -2, -10. So we have vertex at -2, -10. All right, so that means that our range values here are going to be all of our y values greater than or equal to -10. So that's our range. Now the vertex is at -2, -10. Vertex is at -2, -10. So that's going to give us some information there as well. Now, let's look at the values of the axis of symmetry. So if I take this parabola and I divide it in half, we're going to have an axis of symmetry that's got an x value there of -10, right? Of -2. So we've got it over here at -2. Our axis of symmetry is told to us by this value over here. So we've got an axis of symmetry at -2. We've got the vertex sitting at -2, -10. And -10 is the minimum value. That's the minimum value. That's going to be the smallest value before it starts going up and up on that side. So we can take a look at the graph of that parabola, or we can take a look at the A value, B value, and C value and look to see what we are ending up with. So let's kind of take that apart and see what's happening with that. All right, I'm going to leave that parabola on there for just 1 second, and let's talk about some values here. So when we have a graph in the standard form, remember standard form is f of x equal ax squared plus bx plus c. All right, so if I look at that, a cannot be equal to 0. And we also know that the graph of this function is a parabola, right? It's going to be a parabola. Now, if this a value, if that a value is greater than 0, then that means the parabola is going to open upward. If that a value is less than 0, so negative value, then it's going to open downward. So if a is greater than 0, you have a parabola opening up. Other way if it's a negative value. Now the axis of symmetry is going to be found by x, which is your axis of symmetry, equal negative b over 2 times a. All right, so if we take so let's plug in our a value is 2, so a equal 2, b equal 8, and c equal 2, negative 2. All right, so we're going to take that negative, so the axis of symmetry is x equal negative b over 2a, so negative 8 over 2 times 2. So that equal negative 8 over 4, and then that reduces to negative 2. So what did we know about this parabola over here? Was we knew that that vertex, let me get it right on there for you like we had it earlier, is at negative 2, negative 10. So our axis of symmetry is at negative 2. So what we just learned is that we can find our axis of symmetry at that negative b over 2a and plug in those numbers. All right, so we know the direction based on the a value. We know how to find our axis of symmetry as well. And then we know how to find that x and y coordinate of the y value. So how do we know then, if we know that the vertex is at negative 2, how do we know that that's at negative 10? So the axis of symmetry is at x equal negative 2. Now the x coordinate is that negative 2 value, right? So we know that that's that negative 2 value. That's right there. And then the y coordinate of the vertex is the y value of the function. The y value of the function for x equal negative b over 2a. So y equal f of negative b over 2a. So what did we do? Well, we plugged in 0. So we've got negative 2, 0. That's our y value, the function of negative b over 2a. That's our y value. All right, so then we know that the y-intercept is at 0, 0, negative 0, and then the c value. So 0, negative 2. So see that? 0, and we've got the c value. 0 and the c value gets us the y-intercept. So even if you had this value and then you had this value and you were doing this by hand, you already know then what's happening with a parabola once you look at each of the component pieces of the standard form. So let's see what we know before we start plugging into Desmos to check, and then that way we can again use Desmos as a way to check our work once we already really kind of know what's going on with a parabola. So we know that the standard form of a quadratic function is f of x equal ax squared plus bx plus c. So suppose we want to know what the graph of y equal x squared plus 2x plus 3 is. So suppose we want to first graph it by hand and then check our work in Desmos. Let's do this in about 5 steps here. So step number 1, we want to identify a, b, and c. So a is 1, right? If we don't have something in front of that x squared value, we're going to assume that's 1. B is 2, and c is 3. All right, so we've identified those. Now, step 2, we want to find the axis of symmetry, which is at x equal negative b over 2 times a. So that means equal negative, and then our b value is 2, over 2 times our a value, which is 1. So that equal 2 over 2, which is 1. So our axis of symmetry is at x equal negative 1. Sorry, didn't mean to forget that. X equal negative 1. So let's find x equal negative 1 right here. So our axis of symmetry is going to go sort of through that negative 1. And I'm going to go ahead and do a little bit of some marking there just for now. So we got an axis of symmetry that goes through x equal negative 1. All right, now we've got a third step here. So step number 3 is the x-coordinate of the vertex is also negative b over 2a. So we got the x-coordinate is negative 1. All right, now the y-coordinate is, we're going to go y equal negative 1 squared, right? We're taking that x-coordinate, plus 2 times negative 1. All we're doing is plugging in that negative 1 value in for x. So it's plus 3, right? So that's 1 squared is 1, plus 2 times negative 1 is negative 2, plus 3. So that gets us negative 2 plus 3 is positive 2. So we got negative 1 plus negative 2, and then add 3 to that, and we get it 2. So we have it at 1. Our y value is negative 2. So I'm going to go up here, and we're going to bring down our value here. So we have an axis of symmetry, or this vertex actually is going to sit here at negative 1, positive 2. So negative 1, positive 2. Let's go up just a little bit and get that done. So we got negative 1, positive 2. So we've got a parabola that's got a vertex at negative 1, positive 2. Now, how did we get the negative 1? Negative b over 2a. Once we figured out what that x value was, then we plugged it into our original, and we got that y value. All right? All right, so that was step number 3. We found the x and y coordinates of the vertex. All right? And then step number 4 now, since the value of c is equal to 3, the y-intercept is 0, 3, right? So the y-intercept is 0, 3. So I've got a y-intercept right here at 0, 3. All right? And we're going to graph its reflection as well. The reflection of 0, 3 is going to be at negative 2, right? Negative 2, 1, 2, 3. So I'm going to graph the reflection there. And now I'm going to go ahead and I'm going to get this parabola sketched over here. So I've got a parabola that's sort of going to look like this. And I've got my vertex, and I've got that. I also know that because a is greater than 0, it's going to open up. All right, that's how I know everything about my parabola before I even begin to sketch it out. All right, so to sketch it out on Desmos. So now let's go ahead and get that function in there. We got y equal x squared plus 2x plus 3. All right, look at that. We've got a parabola that looks just like what we sketched, and we did that because we know all of the different sections in 5 steps, 4 steps, and then we also know the last step, it's just saying that if a is greater than 0, we know that parabola is going to open up. Now let's just kind of go backward. If we have an equation of a quadratic function in standard form, and remember standard form is f of x equal ax squared plus bx plus c, where a cannot be equal to 0. What if we wanted to go back into vertex form? Well, we just learned how to find the vertex of a parabola that is in standard form. So let's go ahead and list out the standard form here of this parabola, and at the end we will graph it on Desmos to check our work. All right, so we've got in standard form, we've got y equal 2x squared plus 10x plus 7. So we want to put this into vertex form because in vertex form, remember, we have x equal negative b over 2a. That's going to give us the x value of the vertex, and then we're going to plug that x value, once we know it, into the original standard form and get our y value, and that's going to get us our vertex. All right, so let's identify a, b, and c here. So a is going to be 2, b is going to be 10, and c is going to be 7. We're not going to need c for this one because we're just looking at the vertex form. So vertex form of this, to find the vertex, we're going to find x equal negative b over 2a. So that means we're going to have negative 10 over 2 times our a value, which is 2, which is equal to negative 10 over 4. And we can reduce that to, we've got negative 2 goes in 10 5 times, and 2. So we've got about 2.5, so equal negative 2.5. All right, so we've got an x value of negative 2.5. All right, now what are we going to do with that? We're just going to plug that in to the original equation every time we see x. So we're going to have so we can figure out our y value. So we have 2 times negative 2.5 squared plus 10 times 2.5 plus 7. All right, so we end up with, at the end, negative 5.5. So we've got our x value is negative 2.5, and our y value is negative 5.5. So we know that that's what the vertex form, what the vertex of this parabola is. Now, do you remember vertex form? If you remember vertex form, we're going to plug this back into vertex form just so we can go a little bit backwards. Now, so I'm going to take this off over here. Since we've got a parabola who's got a vertex at negative 2.5, negative 5.5. So we've got vertex form is y equal, if you remember that, a parentheses x minus h quantity squared plus k. All right, so we've got our a value, which is 2, and we've got, so we can plug that into our vertex form and then substitute. So we have y equal 2, and then we've got x minus negative 2.5, which is our x value, right? We've got that squared plus negative 5.5. All right, so that gets us y equal, we're just putting it into vertex form, 2x plus 2.5 quantity squared minus 5.5. So that gets us back into vertex form. So we've got 2 parentheses x plus 2.5 squared minus 5.5 in vertex form. So we can go back into vertex form, or we also, now that we have it in standard form, we know that our vertex is at negative 2.5, negative 5.5. So now let's do our checking with Desmos, and let's plug that in. So we've got y equal 2x squared plus 10x plus 7. All right, and let me get that out of the way. Let's look to see if we did our work in our vertex correctly. We should have a vertex at negative 2.5, negative 5.5. Now, knowing what you know about that y-intercept, where is that y-intercept going to be? Yep. So if you looked at that value, you know where your y-intercept is. Your y-intercept is over here. It's crossing that y-axis right about there where it's crossing. So we know that value right there. All right, so that's how we get to convert standard form back to vertex form. And really, the important thing is to understand what, again, A, B, and C tell us about that parabola.